Good morning, students. In the previous video, we are seeing how to write the vector and Cartesian equation of the plane when passing points and parallel vectors are given. Okay, so using that, we are going to do the exercise 6.7 third problem. Find parametric form of vector equation and Cartesian equations of the plane passing through the points 2, 2, 1 and 1, minus 2, 3 and parallel to the straight line passing through the points 2, 1, minus 3 and minus 1, 5, minus 8. Okay, see, we have to find parametric form of vector equation and Cartesian equation of the plane. Okay, that required plane passing through the 2 points. So, 2 passing points are given to you. And the required plane parallel to the straight line joining these 2 points. Okay, so to write the equation of the required plane, we need here 2 passing points are given. So, we need to find a parallel vector. Okay, so that parallel vector has to be taken from the straight line joining these 2 points. But we need not write the equation of the straight line. Just how to take the parallel vector from the straight line. So, the denominator, from the denominator of the straight line, we have to collect the parallel vector. So, what is in the denominator? It is nothing but the direction ratios of the vector which is parallel to the straight line. So, to write the direction ratios of the vector which is parallel to the straight line, we have to use this formula. Either x1 minus x2, y1 minus y2 or z1 minus z2 or x2 minus x1, y2 minus y1, z2 minus z1. Okay, so I am using this formula to find the direction ratios of the parallel vector to the line. Okay, so here I am taking the passing points of the straight line. So here I have taken this is x1, y1, z1 and this is x2, y2, z2. So when you substitute minus 1, minus 2 and y2, that is 5 minus 1 and here z2 minus z1 minus 8 plus 3. So here you will have minus 3, 4 and minus 5. Okay. So see now this is the vector. So I am going to write the vector. Here I have written the direction ratios of the parallel vector. Now I am going to write the vector which is parallel to the straight line. What is it? Minus 3i cap plus 4j cap minus 5k cap. So our required plane is parallel to the straight line joining these 2 points. Because of that, our required plane is parallel to this vector. Okay, already I have told our required plane passing through these 2 points. Now our required plane is parallel to this vector. So we can write from the first passing point. From the first passing point, what it is? 2, 2, 1. That we can write as A vector. So A vector is equal to 2i cap plus 2j cap plus k cap. And from the second passing point, 1, minus 2, 3. From that, we can write B vector is equal to I cap minus 2j cap plus 3k cap. And we have found the parallel vector to the line, that is the vector is parallel to the required plane. So C vector is equal to minus 3i cap plus 4j cap minus 5k cap. You see now A vector and B vector are the position vector of the passing points of the required plane. So passing points can be taken in Cartesian form x1, y1, z1. This is x2, y2, z2. And C vector is the parallel vector to the plane. So it can be taken as C1, C2, C3. Okay, so now what is asked? Parametric form of vector equation. See now, how many passing points you are having? 2 passing points and 1 parallel vector. So the formula we can use, R vector is equal to 1 minus S into A vector plus SB vector plus TC vector, where S comma T belongs to R. So if you use this formula, we have to substitute in this formula. We have to substitute A vector, B vector and C vector. Okay, next one, I'm moving to the Cartesian equation. So when 2 passing points and 1 parallel vector is there, the Cartesian equation is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, c1, c2, c3, which is equal to 0. Here I have written x1, y1, z1, it has to be substituted in the first row, and x2 minus x1. So it is 1 minus 2. Next one, minus 2 minus 2. Next, 3 minus 1. So it has to be written as a second row. What is C1, C2, C3? It has to be taken from the parallel vector. So this is the parallel vector. So it will be minus 3, comma 4, comma minus 5. Minus 3, comma 4, comma minus 5. So here I have written minus 3, 4, minus 5, which is equal to 0. So what is 1 minus 2? That is minus 1. Minus 2 minus 2, minus 4. 3 minus 1 is 2. So you have to expand by R1. Okay. So when you expand by R1, you will get, you see now, x minus 2 into, delete the first row on the first column, minus 4 into minus 5, that is 20. So in between you have to write minus. So 4 2s are 8. So when you go to the second element, you have to change the sign. So I have written minus. So it has to be written within the bracket because this minus is common to both the terms. So okay, delete the first row on the second column. Minus 1 into minus 5 is 5. You have to write minus in between. So when you multiply these two, it is minus 6. So I have written plus 6. Plus z minus 1 into, delete the first row on the third column. Minus 1 into 4 is minus 4. You have to write minus in between in the formula, and when you multiply these two, it is 12. So here you will have minus 12, which is equal to 0. Here 20 minus 8 is 12, and here 5 plus 6 is 11, and minus 4 minus 12 is minus 16. So when you take this number and multiply with the bracket terms, so 12x and 12 into minus 2 is minus 24, 11 into minus y, it is minus 11y, 11 into 2 is 22. So you see that here what I read, the previous step, it is minus of y minus 2. Next step, I apply the minus to these two terms. So it is minus into y is minus y, minus into minus is plus 2. So here I didn't use the bracket because I have applied the minus to both the terms. This step is very, very important. Plus here plus minus 16 into z, that is minus 16z. Minus 1 into minus 16 is plus 16. So when you arrange x, y, z and the numbers has to be calculated. So the answer is plus 14. So this is the Cartesian equation of the plane. Okay, so we'll move to the next problem. You see that, find the vector equation and Cartesian equation of the plane passing through the point and perpendicular to the plane and parallel to the line. Okay, so see that we have to write the vector equation. It is not mentioned parametric or non-parametric. So if it is not mentioned, we can go for the parametric equation. Okay, and Cartesian equation of the plane we have to write. You see that what is first given? Your record plane passing through the point. So we'll have one passing point, and the record plane is perpendicular to another plane. Okay, so if two planes are perpendicular, the normal to, that is normal means the perpendicular line to one plane is parallel to another plane. So here record plane is perpendicular to the given plane. Because of that, the record plane is parallel to the normal of this plane. Okay, and also given what it is, the record plane is parallel to the straight line. So here the required plane is parallel to the straight line. So that means the required plane is parallel to the parallel vector of the straight line. So how to take the parallel vector? You have to take from the denominator of the straight line. So here you are having 3 minus 1, 1. So you have to write as a vector. So see now the required plane passing through one point, that is, this is the point, passing point. So from that we can write a vector. What is your a vector? I cap minus 2j cap plus 4k cap, and you take this the given plane. From the given plane you have to find the normal. So what is the normal vector of this plane? That is I cap plus 2j cap minus 3k cap. So your required plane is parallel to the normal of this given plane. So your b vector is equal to I cap plus 2j cap minus 3k cap. And from this line, from the denominator of the line, we can write the one more parallel vector to the required plane. So that is c vector is equal to 3i cap minus j cap plus k cap. So I have written the three vectors. So from the three vectors, the first one is the position vector of the passing point. B vector and c vector are the parallel vectors to the required plane. So in the Cartesian form, how I have mentioned this, it's a passing point, one passing point. So it is, I have denoted as x1, y1, z1. These two are parallel vectors. So I have taken b1, b2, b3, c1, c2, c3. Okay. So now you are having one passing point, two parallel vectors. So we are going to write the vector equation of the plane in the parametric form. So you have to use the formula r vector is equal to a vector plus sb vector plus tc vector. So here we have mentioned the vector, so you have to substitute here in this formula. And next one, Cartesian equation of the plane. So one passing point and two parallel vectors are given. The Cartesian equation is x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3, which is equal to 0. So see that x1, y1, z1 is I have written here. So you have to substitute. And b1, b2, b3 is 1, 2, minus 3. So you have to write as a second row. c1, c2, c3 is the third row. We have to write in the third row. So which is equal to 0. You have to expand by r1. So the second term you have to be careful. The minus has to be, you have to change the sign of the second term. So here I have written minus. So minus has to be applied to both the terms. So it will become minus y minus 2. Okay. So you have to multiply with the corresponding numbers and you have to get the answer as x plus 10y plus 7z minus 9 is equal to 0. So we'll move to the next problem. Find the vector and Cartesian equation of the plane containing the line. So the whole line, where it is on the plane. The required plane contains this line and the required plane perpendicular to another plane. Okay, so see that because of this word containing, so the whole line lie on the plane. So from this line we can take the passing point as well as the parallel vector. So when I teach the equation of the straight line, so I have said the vector without parameter is nothing but the position vector of the passing point of the line, and the vector with the parameter is nothing but the parallel vector to the line. So here your required plane contains the whole line. That means the straight line lie on the plane. So we can take the passing point of the line as well as the parallel vector. So now you are having for the required plane one passing point and one parallel vector. Okay, and also given in the problem your required plane is perpendicular to the given plane. So perpendicular to another plane. If the two planes are perpendicular, the normal to one plane is parallel to the required plane. Okay, so from the given plane you have to take the normal. So which is the normal? After the dot you will have the vector, that is the normal vector to this plane. So that is parallel to the required plane. So we'll have now one passing point and two parallel vectors. So the passing point has to be taken from the line. So that is I cap minus j cap plus 3k cap. That is the position vector of the passing point of the required plane. And two parallel vectors. One vector is taken from the line, another vector is taken from the perpendicular plane. So it is B vector is equal to 2i cap minus j cap plus 4k cap, and C vector is equal to I cap plus 2j cap plus k cap. Okay, so in the Cartesian form, this is the passing point. So you have to write x1, y1, z1. These two are what vectors? Parallel vectors to the required plane. So you have to mention b1, b2, b3, c1, c2, c3. Again, in this problem, we are having one passing point and two parallel vectors. So the vector equation is R vector is equal to A vector plus SB vector plus TC vector. So A vector, B vector, C vector has to be substituted in this formula, and you have to write the vector equation. Coming to the Cartesian equation of the plane, when one passing point and two parallel vectors are given, the equation is x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 whose determinant is equal to 0. So here I have mentioned x1, y1, z1, 1 minus 1, 3. So x minus 1, y plus 1, z minus 3. What is b1, b2, b3? 2 minus 1, 4. That is written in the second row. c1, c2, c3, that is 1, 2, 1 is written in the third row. So if you expand using R1, we'll get the answer. What is the answer? 9x minus 2y minus 5z plus 4 is equal to 0. Okay, so we'll come to the problem number 6. Find the vector and Cartesian form of the equation of the plane passing through three non-collinear points. 3, 6, minus 2, minus 1, minus 2, 6 and 6, 4, minus 2. So here no parallel vector is given, only passing points. How many passing points are given? 3 passing points are given. So from the first point you have to write the position vector of the first point, that is A vector. Next one, from the second point you have to write B vector. From the third point you have to write C vector. All the three vectors are position vectors of the passing points. Okay, so the passing points are mentioned: x1, y1, z1, x2, y2, z2, x3, y3, z3. Okay, we'll come to the vector equation of the plane. When three non-collinear passing points are given, you can use the formula R vector is equal to 1 minus s minus t into A vector plus sb vector plus tc vector, where s comma t belongs to R. This A vector, B vector, C vector has to be substituted in this formula. You will get this answer. So the Cartesian equation of the plane, when three passing points are given, it is nothing but x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, whose determinant value is equal to 0. So we have to substitute in this x1, y1 and the corresponding points. Okay, x minus, what is x1 here? It is 3, so x minus 3, y minus 6, and z minus of minus 2, that is z plus 2. And here in this formula, x2 minus x1, so it is minus 1 minus 3, so that is minus 1 minus 3. Next one, y2 minus y1, minus 2 minus 6, and z2 minus z1, that is 6 minus of minus 2. So 6 plus 2. And the third row, x3 minus x1. So here you will have 6 minus 3. x3 minus x1. So 6 minus 3. y3 minus y1. 4 minus 6. And z3 minus z1. Minus 2 minus of minus 2. So minus 2 plus 2, which is equal to 0. So when you simplify, minus 1 minus 3 is minus 4, minus 2 minus 6 is minus 8, 6 plus 2 is 8, 6 minus 3 is 3, 4 minus 6 is minus 2, minus 2 plus 2 is 0. So you have to expand by R1, you will get the answer as 2x plus 3y plus 4z minus 16 is equal to 0. While expanding by R1, the second term is very important. You have to change the sign. So here I have written minus. This minus has to be applied to both the terms. So it has to be enclosed with the bracket. Next step, you have to remove the bracket. That means you have to apply the minus sign to both the terms. So here I have written minus y plus 6. Here you are having minus 24. So while you are writing minus 24 into y, minus 24 into minus y is plus 24y, minus 24 into 6 is minus 144. Okay, so the remaining you can complete. The Cartesian equation of the plane is 2x plus 3y plus 4z minus 16 is equal to 0. Okay, come to the seventh problem. Find the non-parametric form of vector and Cartesian equation of the plane. So the previous problem, they have given passing points or parallel vector or perpendicular to the plane, like that it is given. Here the parametric form of the vector equation of the plane is given. For this plane, we have to write the non-parametric form and Cartesian equation of the given plane. So our given plane, you see that this vector is without parameter. These two vectors are written along the parameter s and t. So that means the plane, given plane passing through the point. Which point? 6, minus 1, 1. And parallel to these two vectors, because these vectors are enclosed with the parameter, so they are nothing but the parallel vectors of the plane. So therefore one passing point and two parallel vectors are given for this plane. Okay, so now we are going to write the non-parametric form of vector equation of the plane. When one passing point and two parallel vectors are given, the non-parametric form is r vector minus a vector dot b vector cross e vector is equal to 0. So first from this you have to find b vector cross c vector. It's a cross product of two vectors. How to evaluate? It is a determinant. In the first row you have to write I, j, k. In the second row the components of the first vector, that is b vector. Next row you have to write the components of c vector. So when you expand by r1, you will get this answer. What is the answer you are getting? So minus 6 I cap minus 10 j cap plus 14 k cap. Okay, so this b vector cross c vector has to be substituted in this first equation. Also a vector also has to be substituted. So the first equation implies r vector minus a vector. So this is the a vector. Okay, I have substituted here dot b vector cross c vector. So we have found b vector cross c vector. So I have written here, which is equal to 0. Now you have to distribute the dot product to the vectors. Take this vector r vector dot this vector. So I have written first. So here you will have minus. So I have written the minus, and I am going to take the dot product between these two vectors. So 6 into minus 6 is minus 36. Minus 1 into minus 10 is plus 10, and 1 into 14 is plus 14 is equal to 0. So when you simplify, you will get the answer as minus 12. So minus into minus plus 12. So this is the non-parametric equation of the plane when one passing points and two parallel vectors are given. So next, what is asked? Cartesian equation also asked. So we can use the determinant formula from the non-parametric vector equation. From that we can find the Cartesian equation also. So we have to substitute r vector as xi cap plus yj cap plus zk cap in the non-parametric vector equation of the plane. So in the place of r vector, I have substituted this vector. Next, I am going to take the dot product between these two. So how to take the dot product? Multiply the same components and then add. So minus 6 into x is minus 6x, minus 10 into y is minus 10y, plus 14 into z is plus 14z. Already here you are having plus 12 is equal to 0. When you divide it by minus 2, you will get the answer as 3x plus 4y minus 7z minus 6 is equal to 0. Thank you, students.